Good afternoon, everyone. My name is Scott Draves. I'm here from 2 Sigma Open Source to talk to you about the Beaker Notebook and its polyglot visualization capabilities. And while I'm speaking, I know a lot of you are online, but you can actually get started right now. Our website is beakernotebook.com. We have Twitter. Everything we do is open source. Beaker is multi-platform, so if you've got a computer, it can probably run it. In particular, we have a Docker container, Docker's gotten really good the past year, and I would say that's actually the easiest way to run Beaker these days if you're into that. We have an Electron native version of Beaker, so you can run it as a sort of a regular application with its own menus and windows. And we have a hosted web application, so just like you can run Beaker in the cloud on our servers for free, and a publication server for sharing notebooks and sharing information. And so Beaker comes from 2 Sigma, the company where I work, and 2 Sigma is a technology company that is in the business of investment management. And what we do is apply data science and machine learning to large quantities of data in order to study it, develop sort of algorithmic models, and ultimately predict the future. And 2 Sigma is the tool that we developed originally internally for our own use, for our own data scientists, our own modelers. And we've released it as open source, so scientists all over the world can use it to do their own work. And our sort of philosophy is that the batteries are included. That's our sort of design or our user interface philosophy, and so that you can get your work done faster. So Beaker tries to sort of take care of things for you instead of and get out of your way, so that you can sort of get into the zone with your data and your code and sort of do your visualizations and get your job done. And it's the Beaker Notebook. After Fernando's amazing talk this morning, I probably don't really have to sell you that much on the notebook metaphor, but I do want to make a point. So let me just sort of review that. Here are, the notebook, the idea of sort of a laboratory notebook is kind of almost the foundation of science. The idea that we make a record, we write things down instead of sort of trying to remember what we did yesterday or last week. That's what objective is. That's where quantitative begins. And so, there's a long tradition of the notebook in science. And here's a few quick examples of images of sort of historic and traditional laboratory notebooks. You actually might be able to identify some of the scientists in question. But what I want to mention here is that in notebooks, there's a lot of stuff gets written down, or a lot of stuff gets recorded in them. Prose, literally writing down notes, tables of data, pictures that you draw yourself, mathematical equations. It's really, old coffee stains and who knows what can show up in a notebook. And what Beaker does is really sort of update this idea, sort of for the digital age. And so in Beaker, we have the same kind of multimedia environment where you can have pictures and tables and graphs and prose and math. But there's one special new ingredient that people didn't do with paper, one new sort of medium that Beaker notebooks can handle, and that's code. So these days, we have computers and we program them, and that's how we study their data and model it. But that begs the question of what language this code is in. And there's nearly no one good answer to it. And so our decision was to leave the language as a variable. And so Beaker supports a whole bunch of languages. Here's a list of the major ones. It's really standards from data science like Python and R, up-and-coming languages like Julia and Clojure, some old stalwarts like Java. JavaScript is actually an important language for Beaker because Beaker is a web application. It's mostly written in JavaScript. And although JavaScript isn't a language where you're probably going to be doing a lot of your sort of numeric crunching, what you might call your modeling, it is a good language for interaction, especially interaction in the web browser. And it's a great language for data visualization, witnessed by, with packages, best exemplified maybe most famously by D3. And say Scala for Spark. There's all kinds of languages. Really each language is good for something. There's lots of reasons why you would want to sort of change languages or mix languages. Just a few examples is collaboration. Say you're a Python programmer, but you want to collaborate with somebody who's an R programmer. You're doing a notebook together. It's difficult. You don't have to sort of negotiate a compromise. You can each work in your native tongue and let sort of Beaker handle the difference. Another example is legacy code. Say you come onto a project and they've got just a whole bunch of stuff in Java, and you want to work on it, but you want to work in some more current scripting language. So there's a tons of reasons why this kind of polyglot programming comes in handy, but there's a potential downside of having like a bunch of languages all at once. Really, I think there's like an old story, the Tower of Babel. It doesn't end well. Essentially, lots of languages all at once is really just sort of chaos, because how can they communicate? How can you working in Python and your friend working in R, you load up a data frame and then what do you do? And Beaker's solution to this problem we call autotranslation. And the idea is that when the languages run in Beaker, we define sort of a magic object called the Beaker object. And we use metaprogramming sort of to make that appear or to synchronize the values between all the languages. So here you can see there's a really simple example here at the bottom of this slide. You can just set a variable in Python. You can say beaker.x equals 10, and then in JavaScript, or you can say beaker.x plus 1 and get the value 11. And it's that simple. It just works. And it doesn't work for just simple values like numbers or strings. It works for arrays. It works for dictionaries. It works for data frames. It works for images. It works for all kinds of things. And this basic idea of sort of translating data between languages isn't something we invented. There's computer science or engineering has a long history of what are normally called foreign function interfaces and data interchange formats and things like that. So what we've done, though, with auto-translation is give you a really simple and easy-to-use interface to that kind of communication. And in particular, an interface which is consistent across all the languages. So previously, foreign function interfaces would be defined like, here's the system we use to communicate between Python and R. Here's a different system we have to communicate with JavaScript because it's in the web browser. Here's a third system we have to communicate with Julia. And sort of each one would be a little different. But with Beaker, It's really simple, and they're all the same. And part of how we do that is, because Beaker is a web application, and ultimately it's, the notebook lives in your web browser, and ultimately the values are displayed there and stored there. So we use JSON as like the lingua franca for communicating between the languages. But that's really sort of under the hood. JSON is sort of part of the implementation of auto-translation. It's, as for scientific computing, I think JSON has some serious limitations for handling things like nans, infinities, and also as far as like serialization, performance. So I think ultimately, we'd like to see a shared memory, Apache Arrow kind of implementation of auto-translation. But what we have right now working in, which I'll show you in a few minutes, is just in the web browser. It uses JSON. It's really sort of fast and easy and simple to use. So, and in a few minutes, I'm going to give you a live demo. But before I leave the PowerPoint, there's one thing that I can't give a live demo of here today. I can only show you screenshots, so I'm going to do that here in the PowerPoint instead of switching back and forth. And that's our Spark integration. So this is something that we have just implemented in Beaker, and unfortunately it wasn't finished quite in time for the release. So we just released Beaker 1.7 2 days ago in time for this conference, so that what I show you here, you can actually, everything I show you, you can actually download and run. But we have the Spark integration wasn't quite ready to make the release, but we have it working internally at 2 Sigma. We're big users of Spark, and I would say shortly, I'm not going to promise a date. Shortly, we'll finish the Spark integration, and that will be released as well. So these are just screenshots, but they're not mock-ups. They're actually shots from the working implementation we have. And Spark, as you probably know, is a sort of API or operating system for programming a cluster, giving you easy ways to distribute jobs over many cores in a distributed environment. And Scala is kind of like the native language for programming Spark, and so we started out by integrating Spark into the Scala plugin in Beaker. We'll do the same thing for Python and R eventually, but we're starting out with Scala. And as you can see, when you turn on Spark, you get basically a menu added to the top of your screen that has allows you to connect to the cluster. The green dot means that you are, in fact, connected, and your connection is operating. And if you open that menu, you can see you get some basic abilities like to configure or to open up the regular Spark UI. If you choose to configure, you get a basic control panel, just with a GUI form for setting the number of cores and the amount of memory those cores have. And then this is the good part. When you actually go then to run a cell in the notebook, you automatically get all the progress bars from your jobs completing on the cluster. You can click on any of these jobs, and it opens up the Spark control panel for that job. And like clicking the cancel button in the user interface actually goes and cancels the job on the cluster, not just canceling the execution of that cell. And when the execution is complete, the progress UI is replaced with the result, whatever that is, some table, some number, and all the performance information that was collected from running the job, though, is still accessible in a menu. So this is really a sort of a complete integration of Spark into Beaker, and we're really excited to share it with you shortly. We think it's as good as anything out there. So just to sort of review, Beaker is a sort of notebook user interface for doing data science. It's open source. It has a advanced user interface, and it has a polyglot architecture. Now, that's about half my time, so I'm ready to do the demo. Is that about legible? Okay, great. So the first example I'm going to show you is our connecting Python to JavaScript in order to do some visualization with D3. And so here's some Python code. It's really pretty straightforward. It just creates a random graph. And by graph, I mean like a social network kind of a graph. And so let's just run that cell. It doesn't really have any visible results. If I just look at this variable beaker.graph, you can see it's just a data structure. It's hard to understand, so let's visualize it and figure out sort of what this thing did. So in order to run D3, the first thing you need is actually some HTML in order to create like a div and assign some styles to the elements. And then here's some JavaScript code that creates a force-directed graph. And this code is just copy and pasted from the D3 website. I didn't write this. The only thing I had to do was add this one line at the top, which gets the graph out of the Beaker object. And so, the graph having just been computed in Python. So I just run that cell, and boom, here's my interactive graph on the screen, and we can say, let me just shrink this a little. The thing that I notice when I look at this graph is that these blue nodes are kind of more connected. And maybe that's an insight that I want to share with somebody. So I'm just going to go up here to File, Publish. And this is, with just 2 clicks, I can send my notebook to our sort of publication server. And this, I don't know if you can see the top of the screen. Yes. So it's turned my notebook into a static URL. Now this is a regular web page that you can just look at on a phone or a tablet, or post to Twitter or send to your boss or whatever you want to do. And I'll just say one more thing, that up top you see here's a button that says Open in Beaker Lab. And if you click that button, it will actually open this notebook. Right now, the static web page version of the notebook, all you can really do is look at it. If you actually want to run it and play with the code and change the Java and sort of recompute the visualization, you can open it up in Beaker Lab. And you can do that without even downloading Beaker. You don't have to have Beaker. Beaker Lab is just a hosted web application. Okay, and so let me just go back though. I'll show you another example. I'm going to open, we have a nice sort of file dialog that is sort of familiar to the Mac Finder or the Windows Explorer. And let's see, here's I'm going to do this demo 1. I'm just going to, this is just a standard graph here. But this is a little more interesting. Here's a bit of pandas code that goes and gets some stock data from Yahoo. But what's cool is that the way that data frame was displayed is with this fancy interactive tables. So instead of just a sort of static HTML, there's actually something that you can interact with here. You can say, click on the columns to sort them. You can drag the columns around. Oops. Or like hide a column. You can then maybe once you've figured out something that you like, just say copy to clipboard, and then, oops, wrong application. Paste it into Excel, and then sort of further manipulate your data there. If I'm not really an Excel user, but if you are and you like it, then you can connect to it really easily. Right, so if you return a data frame, instead of sort of plain static HTML, you get a fancy sort of interactive table spreadsheet. And let me I'll just quickly run a few more examples. In addition to our own spreadsheet library and our own actually plotting library, which I don't have time to show you, you can run Bouquet. We love that. Here it is, working inside of Beaker. You can run Plotly. Let's see, here's Plotly, all interacting and working. Again, these are just examples that I copy and pasted from the websites. So that's kind of Beaker's philosophy, is if you're the kind of programmer who likes to find something on the web and then you want to try it out, you're a copy and paste kind of a person, you can sort of create a Frankenstein application. Just anything that you can grab from the web, you can probably make it work in Beaker. So I think we have just a few minutes, so why don't we spend that with questions. Does anyone from the audience have any? Go ahead.
I'm curious that Polyglot thing with the Beaker object is really, really cool.
Thank you.
I'm curious, does that only work with plain old data types? So like what happens if you can't translate something from Python to JavaScript or whatever?
Yeah, so if it's a class that Beaker doesn't know about it, then it can't translate it. It just turns it into a string. So, but we taught it about the basic classes of data science, like arrays and data frames and etc. So you can, but it's not magic. If you have your own magic class, if you have your own class in Python and then you translate that object to R, it's like there's really nothing it can do. So, but you could extend it to add your own classes, but it's not an easy process. Right now, it's really oriented towards handling the basic stuff, like in a dead simple method. Any other questions? In back?
So how would you compare this with Jupyter Notebook? What is the advantages?
So the question is, how does this compare to Jupyter Notebook? The first thing I want to emphasize is that Beaker actually uses the Jupyter kernel for Python and Julia. And so when you're using Beaker, you're actually using Jupyter. We love Jupyter, and we use Jupyter at 2 Sigma as well. As far as, but with the Beaker user interface, what we've done is provided we've sort of done the batteries included thing. We've thrown in a lot of stuff to the user interface that we think is useful, and we've added the, like the one-click publication and tables by default, and really, there's just a lot of stuff. We have, themes exist, are built in, so that you don't have to load up extensions because we already included a bunch of stuff for you. And then we also built the auto-translation mechanism so that the languages can sort of communicate with each other more easily. And I understand that, Jupyter can do multiple languages also. It's no longer just Python. But we have just a different way of communicating that we find simple. Any other questions? There we go. sorry, I can't hear you. The microphone is coming. Why don't you just wait a sec?
Thanks for the lecture. I really like the tool. So I'm wondering how easy it is to debug the JavaScript code, because like there's when you inspect the elements, there's a lot of output. So it might hard to debug the JavaScript code. And the other question is what's the
Sorry, can we do this one at a time? So, so what about the JavaScript code? What you said it was
to debug the code. Like, so here you can easily run and get the output, but when you like real writing the code, you need to like, there's a lot of errors. Like, so can the developers like directly debug the code, write the create the visualization on the Beaker platform?
I'm still not sure I understand your question, but basically you can load in, when you're programming in JavaScript, in Beaker, you can load in new libraries. You can access the data from the other backends. It's not really a full-featured IDE. It is sort of more of a notebook, sandbox for messing around more than doing like large-scale development. And so, what's your other question?
The other question is will it still be free in future?
Sorry, what?
Will it be free in the future, the platform?
Oh yeah, Beaker, the application is open source and will continue to be open source, and Beaker Lab, the hosted version, is free. It will continue to be free, although we will probably add some sort of. Right now, it's kind of in beta. It's not 100% launched. And so one of the things that's missing is like payments. So, if you're a heavy user of Beaker Lab, eventually we're going to have to charge you because you're taking, you're running instances on Amazon, but there'll always be a free tier. We guarantee that. So we are going to add some sort of pay model on Beaker Lab, but it'll continue to be free also.
Thank you.
All right, that's all the time I have. Thank you very much.